So let's do arc cosine of 1 minus 2x. So let's do the same thing we did before. Let's carefully express this as a composite and then unpack from there. So is it a composite of kind of core examples? Well, definitely, right? If I have f of x is equal to the arc cosine function, one of my core classes, and let's say g of x is equal to, well, the linear function 1 minus 2x, this of course implies the composite of these two is the function we're interested in. So that one's pretty painless to do. So let's go through each piece. 1. What's the domain of f? The domain of f is the domain of the arc cosine. So the domain of the arc cosine is what? Well, this is super important we understand this. The domain of the arc cosine is, well, the range of cosine, because it's the inverse function to it. So it's minus 1 to 1. Something I always tell my students is if you can't write down cold the range and the domain of your core function classes, especially ones like your inverse trig functions or your logarithm functions, you have no hope of using them in complicated, or you have no hope of doing difficult problems with them, is what I'm trying to say. Really, what you want to be able to do is to write the graph down cold. If you can write the graph down cold, right, you're in a very good state, right? I expect when I set exams, students to be able to write down the graphs of, say, arc sine, arc cos, and arc tan. They may have to think a bit about how to set it up. You don't need to just completely memorize it, but you need to be able to do it, right? It's crucial. It's one of your absolute core examples. So you need to know the domain, and in this case is that. And second, well, we need to worry about the domain of the inner. So the domain of G, of course, it's everything, thank goodness. So 3, let's write down exactly as we did before. So we need to find, so let's just scroll up a second just to see what it was. So we need to find, so it's this. We need to find all x in the domain of G such that Gx is in the domain of f. So let's literally write that down, just so we've got it in front of us. So need to find all x in the domain of G, so that's minus infinity to infinity, so no real requirements, such that 1 minus 2x is in the domain of f. Okay, so once again, this is the domain of 1 minus 2x, and this is the domain of arc cos. So this isn't so difficult. It may look nasty, but actually it's quite simple. So 1 minus 2x in this closed interval from minus 1 to 1, I'll write it nice and neatly this time. Well, that's if and only if minus 1 is less than or equal to 1 minus 2x is less than or equal to 1. So all I've got to do is kind of solve this equality, or at least put it into a form of x between two things so I get a nice interval. So this is if and only if what? Well, let's add minus 1 to both sides. That doesn't change anything because adding or taking away numbers doesn't reverse, it preserves inequalities. So we're going to take away 1. I'm going to do this to get this 0, so I'm taking away 1. Then, well, I want to get x in the middle because that's, well, the best way to express things. Well, how should I do it? Well, I want to get rid of that minus 2. So to do that, I should multiply by minus a half, because minus a half times minus 2 is 1. But now this is if and only if what? Well, so let me just make sure we understand what I'm doing. I'm going to multiply by minus a half. So what does that do? Well, the first guy, multiplying by minus a half, it just gives a 1 here. Multiplying by minus a half would give me an x here, and multiplying 0 by minus a half is just 0 again. And here's the subtlety, minus a half is negative, so that means it reverses the inequalities. Now that's not too bad. So this is now if and only if, pretty visibly, x is in the interval, well, it's got to be less than or equal to 1 or greater than or equal to 0. It's in here. So this guy now is my answer. This is the domain of arc cosine composed with 1 minus 2x. So we went through exactly the same procedure. This one was easier, really, in the sense that what we needed to do, we didn't need to do anything like sign analysis. We needed to understand, I mean, really the two hardest things here are remembering, essentially, what the domain of arc cosine is, so this closed interval here, and then being able to do this algebra with inequalities to go from this statement to this statement. So those are kind of the two most difficult things about this. But I think it's easier than the previous case, because the previous case we had proper sign analysis to deal with. Okay, let's do another one. So none of these are easy, right? This is kind of a culmination of loads of things we've learned. So these are difficult examples, but they're kind of testing our proper understanding of the core classes. All right, here's one that looks really bad, but actually isn't so bad. So let's take the fourth root So we'll do the fourth root of, so here we go. Let's do the absolute value of log base 2 of x minus 1. Absolute value. So it's the absolute value of everything inside that fourth root. Now, I completely understand if you look at this and go, oh my goodness, this looks horrendous, right? I've got an absolute value in there, that's weird. I've got logarithms, everyone hates logarithms. So this one you kind of recoil at. But again, you have to be totally systematic. There is a completely rigid procedure we go through with these, and if you stick to that procedure, nothing will go wrong. So the first thing to do is to decide, how am I going to break this up into a composite? It looks much more complicated. Well, here's a pretty sensible way to do it, right? Let's do f of x is equal to, okay, so there are several ways, but I'm going to do it like this. 1 over the fourth root of the absolute value of x. That's a bit of a weird one. Why do I do the absolute value? Because the absolute value is nothing too crazy, right? It's just going to make things positive when they're negative. So I think that's not going to be too hard to deal with. This guy, though, well, what's gx? In this case, we should choose gx to be equal to, so I don't like having the absolute value with the gx. I think it's a bit safer to just have that as gx. It's a little bit easier because it's really close to my core function, just log base 2x. So if this is the case, the way we've set it up, brilliant. F composed with gx is equal to what we're looking for. Bingo. Okay, so now we need to work out 1, 2, and 3. So rather than panic, because it just looks so complicated, let's just go through each piece systematically. So the domain of f the outer function. What is it? So this one is kind of a bit confusing. It's not quite one of my core examples, but it's incredibly close. And what is the domain? Well, let's have a think, right? What's the only thing that can go wrong there? The only thing that can really go wrong is if I'm dividing through by 0. Remember the fourth root? When I take a fourth root, that's like a square root. I can do that for any non-negative number. And the absolute value inside is nice, right? It basically means I'm always feeding something non-negative into this. So if I take -1, the absolute value is 1. Sure, I can take a fourth root. So that absolute value is kind of saving the day, but there is one bad point, right, at 0. If x is equal to 0, this would be 0, and the fourth root would be 0. It would be 1 divided by 0, which doesn't make sense. So in this case, this domain is equal to, it's everything apart from 0. So you've got to have pretty good quantitative reasoning skills to see that. You've got to really thought through exactly what's happening. But really this is coming down to the following. So I could have broken it up really carefully as well as another composite, but for simplicity, let's just do this. I mean, what we need, so this is always true, right? So that's good. So it means I can take a fourth root of anything. But the problem is it's happening in the denominator. And as I said, the only real issue is at 0. So the absolute value of x, oh my goodness, the absolute value of x is equal to 0 if and only if x is equal to 0. So that's the only problem point. Okay, if I didn't have the absolute values, so if I didn't have this, if it was just that, I would have to have, I couldn't have negatives. But I'm taking the absolute value, so that kind of saves the day. So the only problem is at 0. Next. I do also want to stress, for a problem like this, you kind of have to do this. You can't just look at it, stare in the sky, and hope an answer is going to appear to you. You need to be really methodical. And there are slight variations on it. You could break it up as a composite in a different way, but you do need to go through this procedure. So really take the time to try to understand every single step slowly. You may be looking at this and thinking, I couldn't do this on my own. And maybe that's true right now, but if you take the time to really study these examples and understand each moment, at some point it'll really click and you'll be able to do any problem I throw at you. So that's the domain of f. What about the domain of g? Well, the domain of g is the domain of this guy. -1 has no effect. It's purely to do with the logarithm. So the only issue is what it would be, it's 0 onwards, isn't it, right? That's the domain of log. Okay, so this is just the domain. So this is why it's so important you know your core classes. And the -1 makes no difference. So let's write down 3. What is 3 telling us? So this one's a bit more delicate. So we need to find all x in the domain of g, so 0 to infinity, such that log 2x minus 1 is in the domain of f. So we take a deep breath. What's the main issue? We basically don't want log base 2x minus 1 to be equal to 0. That's the only problem. All right, that's the problem because I'd be dividing through by 0. So let's work out when that happens. So log to the base 2 of x minus 1 is equal to 0. This is the only potential problem. If and only if log to the base 2 of x is equal to 1. And now there are several things we can do, but let's use a cancellation property, shall we? So take both sides and put them in the exponent with base 2. So 2 log to the base 2x would be equal to 2 to the 1, of course. And I'm doing that because it's going to cancel off. So this is if and only if x is equal to 2. So that's the only problem point, really, right? At least in terms of the domain of f. So let's put all this together. So this implies the domain of my terrifying expression here at the top is equal to what? So first of all, we need to be in here. All right, that's the domain of G. So this is all x in the interval 0 to infinity, such that, well, there's one more thing we need to avoid. We need this to happen, and for that to happen, x can't be equal to 2. Because if x is equal to 2, it's 0. So putting all this together, this would be two intervals. Open interval 0 to 2, union, and then we're jumping over 2 to infinity. I think that's a difficult problem. Without any doubt, that's a hard one. Because you've just got to be really on your toes about what everything means. It's got logarithms, which is difficult. The breakdown at the top is hard. Very difficult example. Right? This would be what I would consider a tricky, but not overly tricky, domain problem in a course like 1A or something like that. But it's incredibly important you can follow each step, right? I really just can't stress enough. And we want to be systematic about this. You need to understand that every problem should be approached the same. You first of all break it into a composite, then you work out the domain of the outer function, the domain of the inner function, and then you think carefully through what possible x's in the domain of the inner function will give a gx, which is in the domain of the outer. And that's kind of the tricky part. And we've seen kind of three examples. First one relied on sign analysis. The second one relied on understanding the domain of the arc cosine function. And this one really relies on understanding some properties of logarithms more than anything else. So difficult example. Next time we will summarize a little bit of the key things to look out for other than just composites, and we'll do a really, really, really difficult example which will tie together lots of different things.